Welcome to the third video clip. We are still looking at mensuration of plane shapes, and we are looking at areas of a triangle. In the last video clip, we considered solving the area of a triangle where we have been given the base and its corresponding height. Now we want to look at the situation where the height is not provided. Instead, we are given two sides and the included angle. What do I mean by giving two sides and the included angle? Let's take, for example, that we are provided with side BC. That is, we are given the length A. We are given the length of side BC. We have been given this, and we are also given this. And then we are also provided with the angle between those two sides. That is angle C in this case. You can call it theta, you can call it whatever you like. Right? You can call it theta, you can call it angle C. How do we obtain the height? Because basically the area of a triangle still remains half base times height. I can decide to say, okay, I want to still use my A as the base. That is my BC as my base. In that case, it means the height has to be what? This length from apex A to the base BC. Let me call that height H. Since it has not been provided, can we get it ourselves? Of course. Looking at this triangle, if I call this point N, I have a right angle triangle there, and I can apply my trigonometrical ratios to obtain H. Since I know theta, I know this hypotenuse B, and I know H, which is my opposite. Please, if you are not conversant with this, kindly run down to our videos on solving right angle triangles. If I look at triangle ANC, let me call it triangle what? From triangle ANC, I can say that sine of this angle, sine theta, is equal to opposite H all over the hypotenuse B. And if, of course, if I cross multiply here, H times 1 will give me H, and this will be what? B sine theta. What does this imply? It means, therefore, that if I'm taking my BC as the base, that is, which is A, then my height H will simply be the other length B times the sine of the included angle. So I can come back and say, oh, therefore, my area will be half times the base, which is the length of side BC, and then times the height. In the case of the height, now I'm going to use B sine theta. Of course, B, of course, if you like, you can write it as AC. Now, this can also be written as half. BC is just A, and then that is B sine theta. What have I arrived at? It simply means that if I'm given two sides of a triangle and the included angle between those two sides, the area of the triangle can be obtained as half the product of those two sides times the sine of the included angle. I can take my theta and write it as C straight away. So this is A, B, then sine of what? Capital C, which represents the angle theta there. Yeah, referring to this C. I can use that instead of using theta. Of course, the same thing can be done if we are given sides AB and side AC, or if we are given side AB and side BC. Let's look at the next slide. Okay, that's what we just arrived at. You can see here our base and then the height AC sine theta as obtained from this. So here we have half AB sine C. When we are given length A and length B, we have this what? Of course, it also means that, let's see what happens in the other cases. Yes, this is the conclusion of it all. In the first case here, you can see where we are given BC and AC. That is, we are given this length A, the colored, the bold one, the A. You are given this, and we are given this. That gives us what? Half AB, sine of the angle between those two sides. And when you are given side C and side A, that gives us half AC, sine of the angle between the two sides. And if we are provided with what? C and B, and of course with the included angle, take note, that will be what? Half BC, sine of that included angle. So you see that we are still doing practically the same thing. It's still a matter of what? Half base times height. It's just that when the height is not provided, the angle, one of the angles will be provided. So let's take some examples on this. We are told here to calculate the area of triangle ABC. As you can see clearly, we have been given side AB, we have been given side BC. Side AB, let's use this naming convention. Side AB will be labeled small c, since it's facing angle C, and side BC will be labeled small a, since it's facing angle A. Therefore, I say, oh, the area of my triangle in this case will be half what? AC, those are the two sides that are provided. And then the sine of the angle in between the two of them, which is sine of B, and that is 47. So which means the area of this triangle will be what? Half times A, 11, times C, 7, times the sine of 47. That's it, AC sine B. That's it on a very neat form. And then you can progress. Sine 47 is 0.7314. And then we have 77/2 there. And then you can compute the rest. The area of that triangle is 28.16 centimeter square. Let's take one more. Here, we are given that the area of the triangle that is shown below is 12 centimeters square. What is the value of angle theta? Oh, the area has been provided. Two sides, 8 centimeters and 5 centimeters are provided, but the included angle is now missing. It's okay, no problem. We know how to relate this. We know that the area of a triangle is what? Half the two given sides, 8, 5, and the sine of the angle between the two of them. That's all. Since we have been provided with the area, we can just put in there, substitute 12. Here we have 8 times 5, 40, divided by 2. That gives me 20 times the sine of theta. So we can just manipulate this to get our theta. Let's look at the next slide. So that's it there. QR. How did they get QR? Let's see how we arrive at QR. Let's explain this. Small letter Q will be there to represent as the side facing angle Q. Small letter R is this as the side facing angle R. So that's how we have half Q and then R, and then the sine of the angle facing the sine of the angle between the two of them, which is P. There. So we substitute half times 8 times 5, which we've done earlier on. And from there we have that theta is what? Sine theta is 12/20. And then we find theta, which is the sine inverse of 0.6. And that gives us 36.8. I'm sure we're catching fun with this. That brings us to the end of video clip 3. We're still on measuration of plane shapes, looking at area of a triangle.